recorded now. So we started finding LCD yesterday, so we will continue. This is still section 6.3. All right. Let's start. Let me share the desktop. Okay, so where's my desktop here? All right. So open from Math 115 is 6.3. So yesterday, this is what we did. We found the LCD. Yeah. Now let's do more. One more. What is the LCD of number 4? So find the LCD of 2 over, did I write these or not? X squared plus 5x plus 6 and x over x squared minus 9 and 3 over x plus 3 squared. So 3 things. Any idea what we're going to do? Factor out the bottom. Yes, the denominator only. So x squared plus 5x plus 6, how do we factor it out? X plus 2 times x plus 3. Good. X squared over 9, how do we factor it out? X plus 3 times x minus 3. Yes. Or the last one is already been factored, right? X plus 3 squared. Okay. Now, to find the LCD, yeah. So, can you guys put all your cell phone inside so you're not distracted? Yes? Okay, because otherwise I'm going to put it here. Okay. So, what is the LCD? X plus 2. What is the highest exponent for x plus 2? Just 1, nothing. Right? X plus 3. What is the highest exponent of x plus 3? Square. What else? X minus 3. What is the highest exponent? 1. That's it. Yeah. So this is your LCD. So we list all the distinct factors, and then when we list the distinct factors, we use the highest exponent. Now let's do one more. Find the LCD of 2 over 6 x squared y z cubed. And let's see, what is it? 30 of, not 30. This is not 2 either, I'm sorry. Let me put 5. Yeah. And then not 30, but 3. 3 of 20, 27, no, not 3 then. Say 5. 27, x to the 5th, y squared z. So let's factor out the denominator. 6. What is 6? 2 times 3. So 2 times 3 is 3x squared y z cubed. 27. Can we write the prime factorization of 27? What is the prime factorization of 27? 3 times 9, but 9 is not prime, right? So what is that? So 27 is 3 times 9. Then what do you do? 3, 3. So what is 27? 3 cubed. Yes. 3 cubed times x to the 5th times y squared times z. Good. So we completely factored them. Now, what is the LCD? 2. Right? Okay. 3. What is the highest exponent for 3? 2. Okay. X to the what? fifth. Y to the square. And how about Z? Z cubed. Yes. So 2 times 3 cubed, that is 54. X to the fifth, Y squared, Z cubed. Yeah. Alright? Yes, no? Okay, good. So that's the LCD. Now, why do I need LCD? Later on, I need to write it so that we can add or subtract using the LCD. But now, let's do the addition and subtraction with like denominators first. So B, did I label the LCD as A? Okay, so this is the addition and subtraction of like fractions. Okay. So to give you an example, what happens if I have to add or subtract? So number one, that's easy. X squared divided by x squared minus 9 minus 3x divided by x squared minus 9. So, how are you going to add these or subtract these? And then number two, we have x plus 1 over, oh, actually, no. Sorry. 70 squared minus t plus 5 over b plus 2 minus 3t squared minus 60 minus 2 over t plus 2. Alright, so let's do these two problems first. Now, for number one, what do I do? Do I have common denominator? Yes. So I can just use it, right? So if I have A over C plus B over C, this is equal to A plus B over C. And same thing with minus. A over C minus B over C, A minus B over C. Same thing. It works for both. So I have common denominator. Here, do I have common denominator? Yes, so I can just use it. X squared minus 9. What do I have on the numerator? X squared minus 3x. Yes. Now, can I simplify? Well, let's factor the numerator and denominator. X times x minus 3. Can I factor out x squared minus 9? What is it? X plus 3 times x minus 3. Alright. So now, these cancel. Yes. So this is equal to x over x plus 3. So the x minus 3 cancel. So doable? Okay. Good. Now, something that you have to be careful on with the minus sign is, look at this minus here. Yeah, what happens to this minus? It applies to which one? To the whole thing. Yeah, so it looks like we have a minus in front of a parenthesis in this case. Yeah. All right, so anyway, here, what is my denominator? B plus 2. Yes. Okay, so then what do we have? So I have common denominator, I can use it. And what do I have on top? 7b squared minus b plus 5, and then minus what? 3b squared, and then plus 6b plus 2. Yeah, so make sure that we distribute the negative. So write a note here. Distribute the negative sign. So look at this, minus 3b squared plus 6b plus 2. So what do I have now? 4b squared plus 5b plus 7 divided by b plus 2. Say it again? No. So for example, if I have negative half, so you could write it as negative 1 over 2. Right? Or you could write it as 1 over negative 2. So you need to choose which one. Now, in this case, will you choose the negative to be on top or on the bottom? On top. So then it doesn't affect the denominator. You have to choose. You have to choose one. Yeah, you have to associate the negative with either numerator or denominator. Most likely, it is the numerator, not the denominator. Good question. Now, let me ask you, is this factorable? So, what is it? The product is what? 28. The sum is 5. Is it? 28 is what? 1 times 28. It doesn't work. What is it? 2 times 14. And then 4 times 7. Anything else? No. So anything gives you 5 here? No. So this is not factorable, meaning what? We're done. Yeah, because this is not factorable. Yeah. So we're done. Okay. If it's factorable, then what? Well, then we have to factor it, and then probably we will cancel. But this is not factorable. Yeah. One more? Okay, so let's do one more. Are you done? I'm going to the next page. Yeah. Okay, so one more. So this is not factorable. That's why we stop. Otherwise, we still continue. So one more. Number 3. All right. X cubed plus 4x minus 3 divided by 5x squared minus 10x minus 4x plus 5 divided by 5x squared minus 10x. All right. So can you try it really quick and tell me the answers? So what we will have on top? X cubed minus 8. So is x cubed minus 8 factorable? Yes. So this is the difference of 2 perfect cubes. So what will this be? So same denominator, we will use them. So x cubed plus 4x minus 3, and then minus 4x minus 5. Yes. So remember, the minus applies to the numerator. Yeah, times this. So this is x cubed minus 8 divided by 5x squared minus 10x. Yes. So let's see. Can we factor out 5x squared minus 10x? What is it? 5x multiplied by x minus 2. Yes. Can we factor out x cubed minus 8? Yes. What formula do we use? A cubed minus b cubed is equal to a minus b multiplied by a squared plus ab plus b squared. So here you will have x cubed minus 2q. Okay? So your a is your x, your b is your 2. So what is a minus b then? X minus 2. What is x squared? What is a squared? It's x squared. Plus ab. What is ab? 2x. Plus 4. Yes. B squared. So your a is x, your b is 2. So then you have to substitute here. Okay. Now which one cancels? Yeah. So what's your answer? X squared plus 2x plus 4 divided by 5. Yes or no? Yes? Okay. So now we're done. So what did we just do? Add or subtract using what happened to the denominator? Like denominators. Yeah. So the denominators are like denominators. Okay. So we do next will be unlike denominators. So we're done with 6.3 now. Can I clarify anything before we move? So if we have minus, we apply it to the top. Yeah, the numerator. Okay. All right. So that we have common denominator on the bottom. Yeah. Good. So let's save this. Okay. And let's move on to 6.4. So we're done with 6.3. Addition, subtraction, and LCD. So we add and subtracted fractions, rational expressions with equal denominators. So now is 6.4. Addition and subtraction with unlike denominators. So we're going to have to find the LCD in this case. So this is 6.4. Right? Okay, so let's start. Share. All right, so 6.4 is addition and subtraction with unlike denominator. So we have to find LCD first. Okay, so let me see. Let's see. How about if we have? Hold on, let me just see here. All right. So let's start with the simple one. So number 1. Oh. So add or subtract. So number 1. 3a divided by a squared minus 9 plus a over a plus 3. In general, this is longer than usual, in general. And then number 2, let's see here. T minus 3 over T cubed minus 1 minus 2 divided by 1 minus T cubed. Okay. And then number 3, we have 6 over a squared plus a minus 2 plus 4 over, so change it to plus 4 over a squared minus 4a plus 3. Good. So for number 1, what do we do first? Can we just add the top? No, we want to have LCD. So let's factor out. How do we factor out a squared minus 9? What is it? A plus 3 times a minus 3. Now, what is the LCD? What is the LCD? A plus 3, what is the exponent? 1, right? A minus 3, what is the highest exponent? 1 also. So that's our LCD. Okay? So I'm going to rewrite both in terms of the LCD. So a plus 3, a minus 3. A plus 3, a minus 3. So I need to use the LCD, and then I have to add them after I have the LCD. So far so good? Okay. Now let's see here. What's on top here? Oh, on the bottom I already have a plus 3, a minus 3. What's on top? 3a. So we copy. How about this? Is it missing something? Yes. Which one is it missing? A minus 3. So I have to multiply a minus 3 on the bottom and also on the top. Yes. Yeah. So now, if I multiply the top by a minus 3, what do I have? A squared minus 3a. All right. Yes? Okay. Now it's easy. Why? Because I have common denominator, which is a plus 3 times a minus 3. So what do we do to the top? We just add them. If I add 3a plus a squared minus 3a, what will I have? A squared. Yes. Then we are done. I can't do anything else here. We can't cross. Yeah. All right. Good? Okay. Good. Now, number 2. Let's see here. Oh, are these two the same? Look at the denominators first. Are they the same? What is the relationship between this one and this one? They're opposite? Okay. They're opposite, you're right. Yeah, so what if I want to write these in terms of p cubed minus 1? So this is what I'm going to write down. P minus 3 over p cubed minus 1 minus 2. And what did you say about this? This is the opposite of p cubed minus 1? So this is the opposite of p cubed minus 1. So this is how we write, oh, this is the opposite of p cubed minus 1. Yes. Then you don't have common denominator, right? So in order to have common denominator, the denominator should be exactly the same, including the sign also. So now I'm going to change the sign here. I'm not going to use this one. So I'm going to change this to plus. Yeah, I'm not going to let these negatives stay here. Why? Because then I don't have common denominator. My goal is to have common denominator. Alright? So I'm not going to leave it here. But what I'm saying is 1 minus p cubed, this is the opposite of p cubed minus 1, which is negative of p cubed minus 1. That's why I wrote this. The 1 minus p cubed is the opposite of p cubed minus 1. Did you see from here to here? Yes. So I'm just substituting it. I'm just saying this is the opposite of p cubed minus 1. Yeah. Now what we do next is, what do I do here? Do I leave this here? The negative? No, then you have to adjust the sign here. So this is p minus 3 over p cubed minus 1. And then what happens when you adjust the sign here? It becomes plus 2 over p cubed minus 1. Is it okay? Does that make sense or no? Yeah. So now this is plus because I am canceling these two signs, negative and negative. Yeah. So what do I have now? Do I have common denominator? Yes, which is p cubed minus 1. What do I have on top? p minus 1. Okay. Good. All right, now is it factorable? Let's try. So p cubed minus 1, is p cubed minus 1 factorable? Yes or no? Is p cubed a perfect cube? Yes. Is 1 a perfect cube? Yes. So then it's factorable. I could use this. A cubed minus b cubed. What is the formula? A minus b times a squared plus ab plus b squared. All right. So this is p cubed minus 1 cubed. So your a is p, and our b is 1. And I'm going to substitute it here. So a minus b. What is a minus b? B minus 1. A squared. What is a squared? What is a squared? B squared. Plus AB. So plus, what is AB? B. Plus B squared. B squared is 1. Yes. Good. So what happened now? You cancel. So my answer will be what? 1 over B squared plus B plus 1. Yes or no? Doable? Okay. Oh, by the way, I sent you an email yesterday about the quizzes, right? Okay, so please read them as soon as possible. Yeah. Don't wait till Sunday night. And then, oh, I haven't done 2 quizzes. No. Each quiz, you have how many chances? 3. And some of them, I think I gave you more, right? But some of them, no. So whatever attempts you have there, I'm not going to change it. Yeah. But some of them, I think I gave 4 or 5. Didn't I? Or it was only 3. I think some of them are 4 or 5. Yeah, but some of them are 3. So we will keep the number of attempts. Whatever it is that you have over there. Yeah. Now let's do one more that looks like this. This is because your LCD, your denominators are opposite. So let's do one more that looks like this. Can you try this one? So let me copy this one first. Copy. So we'll do it on the next page. And let's do one more with denominator opposite. Let me see which one. There's not too many problems that look like that. Okay. So here, 1 minus 6m divided by 1 minus m cubed minus 5 over m cubed minus 1. All right. So keep it in m cubed minus 1. Leave it in m cubed minus 1. So you know the relation between both. Okay. All right. So what would you do here? Are they the same, 1 minus m cubed and m cubed minus 1? No. What is the relationship between those two? They're the opposite. So then what? So what would you do here if they're opposites? Yeah, what would you do if they're opposite? Well, you write them as opposite, right? Okay. How do you write that 1 minus m cubed is the opposite of m cubed minus 1? Negative, so 1 minus m cubed is the opposite of m cubed minus 1. Yes. Yes, you're right. Yeah. 1 minus 6m minus 5 over m cubed minus 1. And then what do you do to this negative on the denominator? What do you do to this negative? Put it up. Okay, so this is negative of 1 minus 6m over m cubed minus 1 minus 5 over m cubed minus 1. And then you have to distribute. Yeah. All right. Okay, so this is m cubed minus 1. So what do you have on top? Negative 1 plus 6m minus 5. So this is 6m minus 6 over m cubed minus 1. All right, now let's see. Is it factorable? Okay, so 6 times m minus 1. How about m cubed minus 1? Is m cubed minus 1 factorable? Yes? What formula do I use? A cubed minus b cubed is, okay, by now you probably memorize it. Is what? Yes, a minus b. So a cubed minus b cubed is a minus b times a squared plus ab plus b squared. Yes? Good. So what is your A here? M. Yes. So our A is M. Our B is 1. So it's A minus B. M minus 1. A squared. M squared plus 1M. So 1M is just M. Plus B squared. B squared is. So that's it. This is 6 over M squared plus M plus 1. Doable? So for number 2 and 4, the denominators are opposite. Denominators are opposite. For number 2 and number 4. The one that we just did. Yeah? Alright. Good. How do you do number 3? Can you try it? So we will try this number 3 and then one more. Yeah. Factor. A squared plus A minus 2. Factor. What is it? What is A squared plus A minus 2? Factor it out. Come on, you guys know. A plus 2, A minus 1. A squared minus 4A plus 3. A minus 3, A minus 1. What's the LCD? A plus 2, what is the highest exponent for A plus 2? Nothing, yeah, real 1. And then, A minus 1, what's the highest exponent? 1. And the last one? A minus 3, yes. Okay, almost done. Well, not really, yes. So now, let's see. On the first term, what is missing? So my LCD is A plus 2, A minus 1, A minus 3. A plus 2, A minus 1, A minus 3. So on the first one, what is missing? A minus 3? Okay, so I have to multiply by, okay, I'm writing really small here, A minus 3 over A minus 3. So what do I have on top? 6A minus 18. Yes. Okay. Okay, that's the first one. The second one, what am I missing? A plus 2. Alright. So for the first one, I'm missing A minus 3. On the second one, I'm missing A plus 2. So what do I have on top? 4A plus 8. Yes. Good. Now, let's carry the denominator together. A plus 2, A minus 1, A minus 3. So, what do you have here? 10A minus 10. Is 10A minus 10 factorable? Yes. 10 times A minus 1, A plus 2, A minus 1, A minus 3. What a minus 1. So my answer is n over a plus 2 a minus 2. I have two problems on my exam that comes from this section. Yeah, so addition, subtraction with unlike denominators. Yeah. So your exam will be longer than chapter 5 exam. So you will take the whole class time and do it. Like last time, the chapter 5 exam was short, right? Maybe 30 minutes you finish, but no, this one no. Because I have two problems from this section. Yeah, so it will be on the exam. So let's do more. Yeah. Okay, what about if we have number 5? Okay, let's see what it is. Okay. X minus 3 over 2 minus x minus x plus 3, this is longer, divided by x plus 2 plus x plus 6 over 4 minus x squared. Yeah, you see this is a little harder. What would you do here? Back at this one first, and then let's see. Then we find the LCD. Okay. Okay, so x minus 3 over 2 minus x minus x plus 3 over x plus 2 plus x plus 6 over, what is 4 minus x squared? How do we factor out 4 minus x squared? 2 plus x and 2 minus x. Yes. All right. Now let's see. I have 2 minus x also, so this is fine. They're not opposite, right? This is 2 minus x and this is 2 minus x. Are they opposite? Not really. How about these? X plus 2 and 2 plus x. Are they opposite? X plus 2 and 2 plus x. Are they opposite? No, they're exactly the same terms. It's just that they are written differently. So do you want to write it as x plus 2 or 2 plus x? 2 plus x, right? Because the other one is 2 minus x. So I'm going to erase this and then just write these as 2 plus x, because otherwise it will be confusing. Why? Because x plus 2 is the same as 2 plus x anyway. They're not opposite. Yeah, so it's different. X minus 2 and 2 minus x are opposite. However, x plus 2 and 2 plus x, are they exactly the same? Exactly the same. Yeah. It's that we write them differently. So you have to know the difference. Okay. Now, what is my LPD? Let me write my LPD here. What is the LPD? What is it? 2 minus x times 2 plus x. Is that it? Yes, it is. So let's write these. Oh, this is 2 minus x and 2 plus x. On the second one, I have the same thing. 2 minus x, 2 plus x. And on the third one, I have the same thing, which is 2 minus x, 2 plus x. Okay. All right. Let's see. Here, what am I missing? 2 plus x? Okay, so I have to multiply by, oh, I have space, so I'm going to put it on the left. So it depends. If you have space on the right, then do it on the right. So it's missing 2 plus x. 2 plus x. Okay. supposed to do here? You FOIL this, what do you have? So 2x minus 6 plus x squared minus 3x. Okay. Or x squared minus x minus x. Yeah, it's just the order is like that. Alright. Now the second one, what am I missing? What is it? 2 minus x? Okay. Okay, now I don't have space again here, right? Now let's FOIL. What do you have when you FOIL? 2x minus x squared plus 6 minus 3x. Oh. Okay. And the last one? Is x plus x. Now let me stop here a little bit. Is it clear or not? Can I clarify anything, or are you guys okay? You're okay? Okay, so let's continue. Alright, so this is, now let's combine the lecture. So this is 2 minus x, 2 plus x. Alright. So on the first term, what do I have here? X squared minus x minus x. Okay. Minus, how about the second term? I have to put parentheses, right? So minus what? Minus, actually, negative x squared. What is it? 2x minus 3x. Negative x plus 6. Plus x plus 6. Alright. Are you okay? Yes? Okay. So remember the minus, you have to distribute, right? So now, what do you have here? X squared, so let's combine minus x minus 6 plus x squared plus x minus 6 plus x plus 6. What is it? 2 minus x, 2 plus x. Alright. So tell me what this is. X squared plus x squared? Is x squared? Oh, and this x cancel? This negative 6 and 6 cancel. 2x squared plus x. How about the number? Negative 6. Over 2 minus x, 2 plus x. Am I okay, or are we making a mistake or not? 2x squared. Okay, now what? What do we do now? So 2x minus x squared plus 6 minus 3x. Yes, is this factorable? Oh, this is very long, isn't it? Okay, so how do we factor this? So x squared minus x minus 6. So how do we factor this? Negative 12 and 1. So what is the other number? 4 and negative 3? Yes. So 2x squared plus x minus 6. What about your x here? 2x squared plus 4x minus 3x minus 6. And then what? 2x squared plus 4x minus 3x plus 6. Alright. Then 2x left with x plus 2 minus factor out 3 x plus 2. Yes. So what's your final answer? X plus 2 times 2x minus 3. Oh, this is your stretch. So x plus 2 times 2x minus 3. This one is 2 minus x times 2 plus x. Okay. Then what? Cancel? Which one? X plus 2 and 2 plus x. Okay. So this is 2x minus 3 over 2 minus x. If you could do this, then it means you mastered this already. Yeah, this is long and difficult. But if you can do it, you mastered it already. Yeah, any questions? Okay. Now, I have 8 minutes. Can I start the new section, 6.5? What homework is due this Sunday? Up to 6.4. Now, tomorrow you have an SI, right? So it's 9 to 12 in B2 101. Yeah. So we have a test when? Wednesday? Okay, so you could probably start going over. I haven't really gone over. Probably I should start instead of 10.5. Let me start 10.6. And then go back to 10.5 because 10.6 is more important. Yeah, that's the equation. Okay, should I do that? Yeah, so start 10.6. Okay, so let me do 10.6 first and then go back to 10.5. We cover both 10.6 and 10.5. No, what did I say? 6.6 and 6.5. Yes. All right, so let me save this. So we're done with 6.4. Let's do 6.6 first. Just give you an idea, so you can probably go over it. The file, new note. Yeah. 6.6 is rational equations, or equations involving rational expressions. So we will do 6.5 when you come back. Yeah. So now this is shorter than adding or subtracting. Why? Because we can clear the denominators. So when adding or subtracting, we cannot. Okay? But if I have an equation, I could clear the denominator. So to give you an example, suppose I have 10 over x squared minus 25 minus 1 over x minus 5 is equal to 3 over x plus 5. Yeah, so this is an example of a rational equation, or equation involving rational expressions. Okay. So as a hint, and this is something you have to remember, okay, you could clear the denominator. It's just that make sure the solution, make sure the solution is in the domain. So check answer by substituting check answer to make sure the answer is in the domain. The value is in the domain. So So that's it. That's what you need to do. And you could clear the denominator. How do you clear the denominator? Any idea how we clear the denominator? How do you clear the denominator? Multiply both sides by LCD. Yes, by multiplying both sides by LCD. So that's what we're going to do. We will clear the denominator. We're not going to carry the denominator. All right. So let's do one problem. Let's do this one. So what am I supposed to do now? Factor? Yes. So tan over x plus 5 times x minus 5 minus 1 over x minus 5 is equal to 3 over x plus 5. Now tell me what is the LCD? X plus 5 times x minus 5. So I'm going to multiply both sides by the LCD. So both sides, remember this one has two sides since this is an equation, so I could clear it. I could multiply both sides by the LCD. X plus 5, x minus 5, x plus 5, x minus 5, x plus 5, x minus 5. So both sides will be multiplied by the LCD. So the x plus 5, x minus 5 cancel. How about these? Cancel. And then? So tan is minus. So when it clears, I only have tan on the left. Minus what? X plus 5. Remember the parentheses. 1 times x plus 5. Is equal to 3 times x minus 5. So you see how this is shorter? Yeah. So that's why I said the 6.4 is the longest one. This is shorter. What is this? And minus x minus 5 is equal to 3x minus 15. So, can you solve this? Of course, right? Negative x plus 5 is equal to 3x minus 15. So what do you do? No, bring the x to one side, the number on the other side. This is not quadratic. This is linear. So you add x both sides? Is that right? Okay. So 5 is equal to 4x minus 15. Then what? You add 15 to both sides. All right. So when we add 15 to both sides, what do we have? 20 is equal to 4x. Yes. And then divide both sides by 4. So x is equal to 5. Yes. Now, is it a solution? Is this in the domain? So does it make denominator equal to 0? So when I substitute here, it makes the denominator equal to 0. So this is not a solution. Why? Because 5 makes the denominator equal to 0, which is undefined. If I substitute 5 here, then it will be undefined, right? So you have 1 over 0. What will happen if you have 1 over 0? Undefined. So This is not a solution. So what is your solution? There's no solution. Oh, what a waste, isn't it? You do all this work and there's no solution. But it happens sometimes. Yeah? Okay. Yes? So this is one of them. As you could see, we cancel the denominator. So starting from here, then there's no more denominator. That's why this is shorter than adding or subtracting. Okay? All right. So what numbers do you have on Sunday? Up to 6.4. Yeah, I didn't do 6.5. On Monday, I will start with 6.6. And then go back to 6.5. Okay? Alrighty. Have a good weekend. Hopefully a lot of you show up to the SI today or tomorrow. Today and tomorrow. Yeah. Did you guys get 25 hours yet? Almost one, but not yet. So then 3 hours the SI. A lot of people finish? Oh, okay. Some people don't? Oh, okay. Those who stay finish? Oh, okay. Good. Okay, good. Okay, so tomorrow 9 to 12 in D201 as usual. And then today is in library 2 to 4, right? 9:30? Yeah. Okay. Have a good weekend. No, the media no. Not the media. Yeah, not the media. The media you just don't do it. Yeah. Which media is the service to you? Oh, okay, no, you don't have to do the media at all. Yeah. Yeah, of course. Yeah, let me proceed for you. Okay, so we're done with 6.4, addition and subtraction with unlike denominators, and we started 6.6.